Now we're ready for the section on oligopoly. With this session, there will be some questions for you to answer, and I will also upload the handouts, the worksheets that we'll do, so that you can print those off and answer them. You can just email me your responses to the worksheet problems in a Word document or an email. So with oligopoly, it's going to be a little bit different than learning about the different types of market structures, perfect competition, monopoly, and monopolistic competition, because we won't actually use a graph for oligopoly. There is a model of oligopoly, which you might see in a textbook, called the kink demand curve, but we're not going to use that. It's certainly not necessary to teach in a regular class, and it's actually not used in the AP curriculum. So it's possible you might encounter it in a different curriculum, but we're not going to do it for now. So the key facts about oligopoly: remember that the oligopolistic market structure, the different firms might produce the identical goods or they might differentiate. So steel would be an example of an undifferentiated oligopoly, where every manufacturer is producing the same commodity, steel. But there aren't very many of them. The industry is dominated by just a few major players. Airline travel, or the automobile industry, are examples of differentiated oligopolies, where there are a few major players, but they actually have slightly differentiated products. In oligopoly, barriers to entry are always high, often because of protected information, so patents or copyrights. Sometimes it's because of vertical integration, where one firm has all the access to a needed resource. In the case of airlines and auto industry, high startup costs might be something that keeps competition out. And the final characteristic here is that firms know and target their competition. And that's what's really helpful to analyze with game theory. So we use this game theory, which is also used in math class, and also it's used in a lot of international relations type classes. So there's a lot of applications for game theory. And what we do is we analyze the decisions of competing corporations in oligopolistic market structures by looking at how they consider their competition's options. So if I'm Coke and I'm thinking, do I launch a new advertising campaign or do I introduce a new flavor, one of the things I take into consideration is, what will Pepsi do? What is Pepsi planning to do? How will Pepsi respond to my action? So game theory is not actually part of the Minnesota Econ Standards, but it's a higher level part of econ that is accessible and really fun for students. So I would really encourage you to try it. And the lesson that we're going to use is actually from the high school economics book, the orange book, and it's on virtual economics. You can find the handouts also on the high school economics website. So this is one of the first slides. It starts out with a little story. Jack left home with a nearly empty gas tank, drove out of his neighborhood, didn't see a gas station, then all of a sudden he saw one, and of course there are two, right? And of course they have exactly the same price. And he's frustrated because he's thinking, why don't we have more competition? And the reason we don't have more competition is because this is an oligopolistic market. So the next slide just differentiates between perfect competition and imperfect competition. And it's very general, right? We're not specifying here monopolistic competition. We're not trying to distinguish between those two. So perfect competition, or perfectly competitive markets, have many, many buyers and sellers, low barriers to entry, identical products, and very little influence on the price of the good. Whereas in imperfectly competitive markets, you have just a few sellers who dominate. They have high barriers to keep out competition. They might be selling identical or differentiated products, but they have a lot of influence over the price of the good. So the first handout that you'll see on the Moodle site involves Curly and Moe. And you should read through this. I would like you to actually email me all of your answers to this, but I'm going to lead you through how this can be looked at as a game theory question. So the information from the handout, which is all written in a narrative form, has here been put into a table. So what we're looking at here is a prisoner's dilemma. Curly and Moe have committed a crime, potentially, I guess together, they're suspected of it. And we can see by looking at this grid that if Curly and Moe both confess, they will both serve 5 years in prison. If they can both hold out and not confess, they'll serve 2 years in prison, and obviously that's preferred. But if one of them confesses and the other doesn't, right, the one who confessed gets off with just 1 year, and the one who doesn't confess goes to prison for 10 years. So there's a strong incentive to confess, because you could save yourself time in prison. So here's how we actually read a game theory grid. We look at each of the boxes represents Mo's strategy and its outcome, and Curly's strategy and its outcome. So we have two players. Mo is on the left, Curly is up top, and we have two strategies, confess or don't confess, right? They each can either confess or not confess. And I'm going to color code here so you can see that the number or the item, the outcome on the left, is always going to respond to the person on the left. And the outcome on the right is going to respond to correspond to the person on the top. So in the first box, if they both confess, right, Mo gets 5 years, Curly gets 5 years. In the second box, if Mo confesses and Curly doesn't, you can see that Mo will have the green outcome of 1 year and Curly will have the maroon outcome of 10 years. Okay, in this third box, the lower left, we can see what happens if Mo doesn't confess and Curly does confess. And in the fourth box, what happens if they both don't confess. So the way we want to read this is we want to look at first, what should Mo do if Curly confesses? So we're going to look at this column. If Curly confesses, what should Mo do? Should he confess and get 5 years or not confess and get 10? What if Curly doesn't confess? Should he confess and get 1 year or not confess and get 2? Well, you can see that in this option, Mo's better off confessing, right? He'd get 5 years versus 10. Here again, he's better off confessing. 1 is better than 2. So Mo has a dominant strategy to confess no matter what Curly does. Even though we know the ideal outcome for the two of them, if they could collude, would be to not confess, we can see that acting individually, anticipating their opponent's strategy, right, that they will both have a dominant strategy of confess. Okay. Oh, I guess I didn't clarify why that would be the case for Curly. You can walk through this and see if Mo confesses, Curly faces the choice, confess or don't confess, and again, 5 years versus 10. And if Mo doesn't confess, Curly faces 1 year versus 2. So again, Curly will also face that. Okay, so a few of the terms that we associate with game theory. The game is the entire scenario, the entire situation. The strategies are the options available to each player. And we're looking at very simple 2x2 grids. There are more complex games. You can have 3x3 grids where each player has 3 possible strategies. We're just going to look at the 2x2. So confess or don't confess. The payoff is what's actually in the cell, what's in the matrix. The 5 years or 10 years or 1 year. The dominant strategy is if, as a player, you would choose the same outcome regardless of what your opponent does. A Nash equilibrium exists when both players have a dominant strategy to be in the same cell, or they have no incentive to change. And collusion is what would happen in this bottom right cell. If they have an incentive to work together, so Coke and Pepsi would have an incentive to collaborate, or 2 gas stations would, because they can have a more favorable outcome that isn't reached in a competitive environment. Okay, so there's a worksheet with the dueling gas stations, and this is the grid for the dueling gas stations, and so you need to complete that assignment on your own. I'll just give you a little hint. Remember, when you're looking at it, I would start with Pat and say, what would Pat do if Alex picks a high price? Right? Should he pick high or low? And now the numbers in the grid are profits, so you want to think about it as higher is better. Higher number in here is better. And if Alex picks low price, should Pat pick high price or low price? So I'm going to leave that one for you to finish. Then we'll move on and we'll talk about this particular game show, which is really, really fun to show to kids. So I know you can't just click on the link here, but if you Google Splitter Steel Golden Balls, Steve and Sarah, you should be able to find this scenario. And in the high school economics workbook, it also has the link. So you should be able to find that on the handouts. Also, I would really encourage you to read the information about how to implement this game in your own class and how to talk about this as a game theory question. So this is the scenario that I would use with students. The numbers in the grid represent how many starbursts they can share. So they can both pick split and they get to share, split the starbursts evenly. They can both pick steel and they each just get 1. But if one player picks split and the other picks steel, the steel player gets to have all 10 of the starbursts. So it's kind of a fun activity to do with students to help them see how they behave and how their opponents behave in class. And then this is the final assignment from the workbook, so the third assignment that you should do for this section. And that is it. We'll come back to trade in the global economy in my third video.